Hi, and welcome to this new coding exercise where I'm going to be implementing a vector class completely from scratch. Okay, my name is Jose Luis and this is Parametric Comp. We do a lot of live streams and computational design tutorials and videos. And if you're watching this video, you are probably here because you've been following my Learning C# Introduction to Computer Programming for Designers, that series where we've been learning how to code from scratch. So this exercise is part of a section where I have explained object-oriented programming, and I have explained a lot of the techniques and nuances of how to create classes and objects and how to work with them in computer programming. Now, what I would like to do is I would like to take all that knowledge and put it together and wrap it up and make an example where we see all of that together working for a very useful example, which is writing a vector class. A class that contains information such as the x, y, z properties of a vector and a lot of operations that we can do with vectors, such as vector algebra, computations that are derived from this. And I would like to use this exercise as a way of solidifying all the information that we have learned in the videos that make up this section, object-oriented programming, but as well to showcase perhaps 2 or 3 more tiny advanced topics that I have not covered in the class, but that I will cover just by example while I'm writing this class. Okay, so if you're interested in learning how to write classes and in particular how to represent vector operations and vector algebra with that, I think you're going to be very interested in this video. Okay, so let's get started. Okay, the first thing we're going to do is I'm going to be implementing this class, this vector class, inside of a console application. But you can think of this as a class that could be inside of a library, inside of whatever. Okay, so I'm going to write here, I'm going to write a public class that is going to be called a vector. All right, and I'm going to try to be a bit more descriptive about text. So I'm going to be using a lot of comments so that we can so that we're really writing a nice class. So this is going to be represents a three-dimensional vector, for example. Okay. Now, what are the main properties that a vector is going to have? Well, I think basically they're going to be x, y, z. It's a very common thing to do. So I'm going to write here properties, and I'm going to say, well, the first one is going to be a public property of the type double that is going to be the x component. All right. And I described in my previous videos how when we write properties, we want to be able to define if people have getting or setting access, whether if they can read or write to these properties. And for x, y, z, we're going to allow people to change x, y, z, no problem. All right, so that's why it's going to have a setter and a getter property. Similarly, for this, I'm going to get for y is going to be a get set property, and for c is also going to be a get set property. All right, so this is going to be the basics. We have 3 properties, x, y, z. Now we need constructors. All right, and I say constructors because we're going to we want to allow people who create vector objects to create them in different ways. Probably the most common constructor that we may want to write is one that takes x, y, z values and stores those values in the properties. Okay, this is a very common thing to do. So for example, I'm going to write a constructor that takes as an input the x, the y, and the z. Okay, and then I'm going to here, I'm going to add some actually, you know what, this is a lot. It's going to be very difficult to read, so maybe I do that by the end of the video. Okay, and then what I do is I say this, I'm going to take the x value that is given to the constructor and store it in the x property of this object here. So this is a very common thing to do. This y equals y and this z equals z. So everything that has been given to me as a constructor, I'm going to store it as x, y, z values. All right. And then in my main class, I can now start creating a couple of simple vectors, such as, for example, I'm going to create a vector v1 or v0, and it's going to be new vector with parameters 1, 2, and 3. All right. And vector v1 is going to be a new vector 4, 5, and 6. I don't know. Okay, I really don't know. And then console write line, and then read line, so that we stop the read key, so that we stop the execution. And then I'm going to print to the console. I'm going to print to the console the value of v0, and I'm going to print to the console the value of v1. All right. And as I do that, we're going to see that I get some really crappy printouts. I just get the namespace and the name of the class as a printout, and that is because I haven't really customized how my vector objects get serialized to strings. I explained in my previous videos how I can add to my class, I can add some overrides to customize how each object gets automatically translated into a string. And I discussed how in C# we have this standard method called the toString method that I can override and say, whatever this was before, I don't want you to use that version anymore. I want you to use the version that prints out to the console a square bracket, that prints square bracket, and then the property x, all right, and then the property y, and then the property z, all right. And then I'm going to close the square bracket, and remember that this dot in C# is optional. I want to try to use it consistently. I just like it. I have a little bit of OCD, but if you don't do it, it's going to be fine. Okay. Now I'm going to print this again, and you can see how now these two vectors get represented in a very nice way with square brackets and with the three properties of the vector. Okay. All right. So we have the basics here. Let's see how we can empower our class a bit more. Something that I may want to do is to give users who work with vectors the possibility of creating vectors also in different ways. Maybe not exactly using XYZ properties, but with other ways. So for example, a very common way to create vectors is to simply create empty vectors from scratch, right? It's a very common thing to just create a vector and then to just create it empty with all the values at 0 and then modify it afterwards. So if I want to be able to give that possibility, so maybe I can create a vector without passing any information, and then the vector gets initialized to the value of 0. Each component gets initialized to the value of 0. This is a very common thing to do. Another very common thing to do is, because I explained in my previous videos how classes get passed by reference, sometimes you want to make sure that if you have an object that you're giving a method, you want to make sure that it's not going to change your original one. So what you may want to do is you may want to pass a copy of that vector. So creating a new vector by copying XYZ properties of another vector is also a very common thing to do. So I'm going to create another constructor, and this is going to blow your mind. This is a constructor for vectors that is going to take another vector as an information. All right. So I'm giving it a vector, and what I want is to create a new vector that is copying XYZ properties from the other vector. So how can I do that? Well, very easy. I can say the x property of this vector is going to be equal to the x property of the other vector, the one that you just gave me. Okay. Another one is going to be this other y, and this dot c is going to be equal to other dot c. All right. And then let's see how that works. So for example, I'm going to create a vector here that is going to be called the 0 vector. And the 0 vector is going to be a vector that I'm going to initialize with no parameters. So if I now copy any, well, did I do 0 with an actual 0? I did. So I'm going to print this, and if I run this, you can see how I just created an empty vector. All right. And I may want to create another vector that is a copy of v1. And this is going to be equal to a new vector where I am copying from v1. So I'm passing v1 as data, and this object is being copied here. So copy of v1. And now you can see how my fourth vector, copy of v1, is a vector that has the exact same values as v1 because they have been copied. All right. So this is also a very, very common technique. Next, what else can we do, or what kind of functionality can we add to our vectors? Well, I think very typically a super common thing to be able to calculate from a vector is its length, right? So how can we do that? Well, I'm going to add, for example, a method that is going to be called getLength, and it's going to return a number that is the length of that vector. So for example, public double get length, and this function is not going to need any data to work with because the only thing that it needs is to know its own, So what I'm going to do here is, first of all, I'm going to calculate, you know that we calculate the length of vectors using the Pythagoras theorem, and I have a video somewhere in my channel where I have done that, so you can check that out. It might be popping up somewhere here if I remember to add that link. And then what I can do is, first of all, I can calculate the square length. All right, and the square length is going to be equal to this x times this x plus this y times this y, and then plus this z times this z. All right, and then what I can calculate is the length by saying that has to be equal to the square root of the square length. And that's the value that I can return. I can return the value of length. So let's see if that works. I'm going to change the vector v1, and I'm going to make v1 3, 4, and 0, because I know that the length of that vector is going to be 5, because it's a perfect whole triangle. I don't know what the name of that is actually. So let me calculate here, for example, console write line v0 dot get length. All right, and let me calculate the same but for v1. All right, if I do this, you can see that the length of this vector is whatever that is, but the length of v1 is a perfect 5, which sounds like things are working well. If I were to calculate the length of 0, hopefully that will also be 0, right? So let me, all right, exactly, and that is also going to be 0. Okay, cool. So what else can we do? Well, turns out that finding the length by calling a method is a very common operation. It's a very common way of designing things. But it turns out that in C# world, there's also the possibility of creating properties that can only be read, okay? And that act as, let's call it like fake variables that give you the impression of variables, but they're not really like that. So it's a very common thing, for example, to say, here I'm going to create a new property. I'm going to call this length, okay? And this property is going to be have only a get property. This is not something that can be changed. And the idea is that what I'm going to do here is that whoever calls the length property of this object, what they're going to be returned is the result of calculating get length. What? Yes, so it's a very common thing to say, well, maybe you can calculate the length by creating a method that returns that value, or you can say, if I type v0.length, you can see that now I can also read the length property of this vector. All right, the functionality is the exact same thing. The only thing that has changed is the UI of the class, if you want, or which possibility are we giving people to access the length of a vector, whether if it is by using a method, by calling a method, or whether if it is by accessing that method from a property. All right. What is the difference? There's absolutely no difference. It makes no difference. It's more of like a perception kind of situation, right? So some people prefer this method, or some people prefer having actual functions that are called get length, get height, get whatever. All right. So I would argue for whatever you feel, whatever you think it feels more natural to you. The only thing that I would definitely argue is that length has to only be get, because if you're letting people change x, y, z, then length, it's absolutely dependent on x, y, z. So you cannot really set the length of a vector without actually changing x, y, z. All right? But what I would also argue is that you choose one or the other, or maybe you want to have both, it doesn't matter. So, but I would like to just have one or the other to make code not very confusing. So what I'm going to do is I'm going to make this private so that nobody else outside of the function, outside of the class can call it, but this property, because it belongs into the class, can actually call the getLength method. All right? This is a design choice. There's no right or wrong here. All right? Let me add a little bit more of functionality. So when we add methods to classes, we can add methods that compute stuff from the class. In this case, for example, computing the length. And I have decided to keep the length as a property because it feels like it's a value that you should get from the vector. That's something, to me, that's a good UI kind of design pattern. I prefer to use methods for things that make changes or that act on the object and change that object permanently. But that, again, it's a very personal choice. It's like how I like writing my code kind of situation, all right? So for example, what I can do is I can write a function that takes, I can write a function that is going to take the vector and it's going to flip it. It's going to change its orientation backwards, okay? So what I can do is I can say public void reverse, all right? It's a function that is void. It doesn't return anything because what it does is it changes this vector permanently, all right? By flipping its orientation. And the way to flip the orientation is by saying whatever x is, make it minus x. Whatever y is, make it minus y. Whatever c is, make it minus c. Okay? And therefore, if I go back to my example, I'm going to clean up a little bit of my code here, or at least I'm going to cancel it. Do I want to delete it or do I want to keep it there? I don't know what I want to do. I'm going to delete it here. So you see how I'm printing v1 here? So if I now say v1.reverse, you can see that this code is changing. It's going to change the code, it's going to change the vector internally. So if I now print, for example, if I print v1 before and v1 after, you can see that is the same vector, but in opposite direction. I have reversed the vector. All right. So again, I personally like using this kind of like properties kind of approach to reading information. But if it is about changing the vector, I prefer using methods because to me, the idea of like, I'm calling reverse on this object, it feels like it's calling for action on this object. All right. It's just a preference. But again, this is a design choice. You may have a different style of writing code, and that's perfectly fine. Another thing that I may want to do is I may want to scale this object, this vector. I may want to multiply it by 10 times, by shrink it by a half, whatever. So something that I can do is I can also say, well, I'm going to create a function called scale. And this function is going to be a void function because it's not going to return anything. It's just going to change the vector that I am at. And what I'm going to do is I'm going to say, well, I'm going to need some information. I'm going to need at least the factor by which you want to scale this vector. All right. So I'm going to say, this function is going to take a double as an input. And then what it's going to do is it's going to multiply the value of x by a factor. It's going to multiply the value of y by a factor. And it's going to multiply the value of c by a factor. All right. I'm going to multiply here. Does that make sense? So let's see. I have vector 1. I have calculated, let me just for the sake of the example, v1 dot length. All right, so I'm going to calculate the length here, and now v1, I'm going to scale it by 0.5. All right, and if that was correct, the length of the vector should always also have been modified by a factor of 0.5. So let's see. I have the vector, I have reversed it, I have then scaled it, and let's see how that works. We have the original vector, then we have the flip vector, the length is 5. Now we have the half vector, and the length is 0.2.5. So half that length, all right? So things are looking okay, all right? So things are looking okay. Now, maybe something that I may also want to do, and this is a super, super common operation, is to unitize a vector. What does that mean? Unitizing a vector means taking whatever that vector and whatever the direction is, keeping that direction, but then shortening it or stretching it so that the length of that vector equals 1. The way to do that is super simple. I think I have a video somewhere on my channel as well, but basically the way you unitize a vector is by dividing each one of the components of that vector by the length of that vector. So let's take a look at this. Public void unitize, and I don't need information here. And what I'm going to do is first I'm going to calculate the length. So double length is going to be equal to the get length method, so the return of get length. So I'm going to calculate the length of my vector by calling the length property. And yes, within a particular vector, I can also call methods that already live in that vector. All right. So within this object, I can use the method that already lives inside of this object. I don't have to call it externally. And what I can do now is I can say, well, then this dot x has to be divided by the length. This dot y has to be divided by the length. And this dot c has to be divided by the length. Okay? How does that sound? Is this making sense? Let's see how that goes. So I'm going to now here go v1 and I'm going to say unitize. All right? And then after that, I'm going to print again the name, the length. I'm going to print again the coordinates of that vector and the length of that vector. Let's see if that works. So here we have that when unitizing it, the components become 0.6 and 0.8, and the overall length has become the value of 1. All right? Awesome. This is great. However, a really tiny detail, and this is me being OCD, top OCD, if you take a closer look at what we've done for unitizing, all right, what we have done is that we have calculated the length, and then we are dividing each one of these components by length, all right? However, we have to be mindful about what's called corner cases. Corner cases are situations in our code that are not going to be often happening. That are going to be only like very, very once in a while happening. But if they do, they may actually break our code or they may lead to unexpected results. What does that mean? Let me show you, for example, if I create a vector called 0, which is just going to be a new vector with 0 for each one of the components. And if I try to unitize that vector, look at what's going to happen. I'm going to run this code and what's going on? Oh yeah, sorry. Let me print you the console. Let me print what's going on here. You see, what I just got is that the 3 components of this vector, now instead of being 0, they turn into nan, or not a number. So I basically destroyed this vector by trying to do a mathematical operation that is not allowed, that is dividing a number by 0. Okay? So, two things that I should do here. First of all, one thing that I should do is I should calculate if the length, once I have calculated it, if the length is equal or less than 0. And if it is, I don't do anything. But if it's not, then I continue doing this. So I would argue that checking here if length is less or equal to 0, then I should probably not continue doing anything in this method. So what I should do is just return. All right? If I run this code now, you can see that now I don't get that error. Okay? And I don't get the error, and the vector stays with coordinates 0, 0, 0. All right? Now, also, something that is very common to do is that because, and this is thinking about the design of this class, all right? Something that is common to do is to say, well, whoever is writing this code, whoever is using this code may want to know if the operation of unitizing was successful or not. Because if it was not, then maybe they want to make some other decisions. So there should be a way for the method to signify or to let the coder know if unitizing the vector was successful or not. The way to do that is very simple. So we can choose to, instead of not returning anything from this function, right? What we may want to choose is to return a Boolean value that represents whether if the operation was successful or whether if it was not. So if the length is less or equal than 0, then I may want to return false to indicate, hey, this didn't work. All right. However, if the operation was successful, then I may just want to return true here. All right. And then I can use this, for example, to make decisions here. So for example, I can say if the result of unitizing of this, if this was true, right, then I can print to the console success. Otherwise, I can print, oh, none, you know? And then, and similarly, I can do that here with 0 unitize, right? So I can be here 0 unitize and then print one or the other. So if I run this code, you can see here we have success, and this vector was unitized, and the length is 1, and oh no, sorry, oh none, and then the vector didn't change. All right, does that make sense? This is being already super picky and super overthinking these things, but we're trying to become better computational designers. So why not spend some time thinking about how do we want to use our code and how do we want our code to be a bit smarter, right? Let's keep going and let's add more functionality to our vector class. Okay, something that is very common to do is to add vectors together. Okay, so one thing that I may want to do is I may want to have a vector, and to a particular vector I may want to add a second vector. All right, so the way we're going to do that is super simple. I'm going to say public void add, and then what I'm going to do is I'm just going to pass to this vector, to this method, I'm going to pass as information another vector. All right, so what we're going to do is we're going to add two vectors together. And what we're going to do is to this x property, I need to add the x property of the other vector. To this y property, I need to add the y property of the other vector. And to this c property, I need to add the c property of the other vector. Let me clean up a little bit of the code here. Let me clean up all this stuff here, and I'm going to console write v0 and v1. And now what I'm going to do is to v0, I'm going to add v1. And the order of operations doesn't matter. And then what I'm going to do now is I'm going to write the value of v0, the value of the vector that I have used to add these two vectors together. Okay, And you can see that my v0 has now changed and now has the value of 4, the value of 6, and the value of 3. So v0 has become the combination of v0 and the v1. Okay. However, and this is where things are going to, now I'm going to start getting into the more advanced stuff on this video. And however, this might be okay to do, because the way I read this code is, to me, is very intuitive. I have v0 and I'm calling the add method on v0 and I'm passing in v1. To me, this feels like I am changing v0 permanently by adding the values of v1 to it. Okay, so that's great. However, I may not want to have, I may not want to actually change the value of v0. What I may want to do is I may want to create a third vector that is the addition of both v0 and v1. So I may want to call that v2, and I may want to do something where I say I want v2 to be equal to the value of v0 plus v1, but I do not want to change any one of the original vectors. I want to keep those values there because I may want to work with them farther down the road. Okay? So that is where, for example, things such as static methods are a really good way to go. So for example, what I may want to do is I may want to create a function somewhere that takes two vectors and then creates a new vector that combines the x and the y properties of both, and then makes a new instance of a vector. But again, without changing any of the two. For that, a good way to go is typically creating static methods in your original class so that that method doesn't belong to any object, but it's a general method, and then you can use it to combine things together, to perform calculations, etc. So I'm going to go all the way down here, and I'm going to write static methods. All right. So I'm going to write here a public static method that is going to be called addition. All right. And this addition method is going to take a vector called A and a vector called B. And I'm missing a return type here. What I'm missing, and this is where the moment comes in. If I have this method that I want to use to take two vectors, combine them together, and return a third vector that is new, the return type of this function is going to be yet another vector. So literally, this is a function that takes two vectors and returns another vector. As simple as that. And what is going to happen here is that I want to say, for example, I'm going to calculate new x is going to be equal to a dot x plus b dot x. All right. Double new y is going to be equal to a dot y plus b dot y. And then double new c is going to be equal to a dot c plus b dot c. And I'm going to create vector v is going to be equal to a new vector that is using those coordinates, new x, new y, new c. All right, and I'm going to return that vector. What just happened here? I declare three variables, new x, new y, new c. I use them to store the addition of the x, the y, and the c coordinates. I created a new vector using those added coordinates, and then I'm returning that vector as part of what this function here does. All right. Now, let's remember, I declare this as static. What that means is that whenever I want to use that, if I want to use it here, for example, what I want to do is I want to create a new vector v2 that is going to be equal to the addition of those two. Because that method is static, it doesn't belong to the object. So I cannot do v0 dot addition. No, this is the add, which is the previous one, the one that changes the object. The only way that I have for accessing that is by calling it directly from the class. So what I do here is I say type vector dot, and you can see that now I have this new functionality that is part of the class that is called addition. And then this takes vector A and vector B, so this is going to be v0 and v1. And because this returns a vector, the combination of both, I'm going to store that in this new variable that I just created. And now I'm going to say console writeLine v2, and let's see if that works. All right, so it looks like it's working. v2 is now a vector that lives in my program, and that is the combination of these two vectors. All right, wonderful. So it turns out that we can use static methods for example, for taking two different vectors, computing some calculations, and then returning the result of those calculations. So let's do a couple more examples of that, because it's a very common and very popular, it's a very common pattern, it's a very popular pattern. So for example, what other things can I do? What other operations do I have between vectors? Well, something that I can do is I can calculate the dot product. All right. So what is the dot product? So if you remember, I have somewhere in my other videos in parametric camp, the dot product of two vectors is a number. Okay. So I'm going to say that the return type of this method has to be a double, and I'm called here dot product between vector A and vector B. And all right, and now what I can do is I can say, okay, what is the x component? Sorry, actually none. Sorry, the dot product, if you remember, you don't have to remember this, but if you remember, the dot product is the simple addition of all the components of the two vectors multiplied. So that is going to be a dot x times a b dot x plus a dot y times b dot y plus a dot c times b dot c. Okay, and I have a lot of videos in my channel where I explain why the dot product is so useful and so popular, and it's like in every basic operation. Okay, and I can just return this. I can return the dot product, or if I want to be a little cleaner, I can just say return this. Okay, and I can just do it in a one line, a one-liner. All right, so let's calculate the dot product between v0 and v1. So vector dot product is going to be between a and b. Sorry, between v0 and v1. And let's print to the console the dot product. If I do that, it turns out that it's a whole number. It's 11. All right, that's great. And yep. And what else can we do? We can calculate the cross product as well. Okay, fine, let's do that. So we're also going to create a new static method. So that's going to be public static, and then the return type is going to be a vector, because if you remember, the cross product between two vectors is a third vector that is perpendicular to them both, and whose length is equal to the area of the parallelogram that is formed between those two. All right. I have some videos also in my channel where I explain the cross product more in detail. All right. So vector A, vector B. All right. And then I always forget what are the calculations for the cross product. Let me look them up. Okay, I found it. I have it here on my side screen. So I never forget this, and I don't think anyone should remember how to do the cross product just mentally, but it's fine. What's important is to remember what the concept is, okay? So the x property of the cross product vector is going to be a dot y times b dot c minus a dot c times b dot y, okay? Double y is going to be equal to, excuse me, a dot c times b dot x minus a dot x times b dot c. Is that correct? I believe so. And double c is going to be equal to a dot x times b dot y minus a dot y times b dot x. All right? And then I can return a new vector with these x, y, and z coordinates. All right? I might be wrong here. I think this is correct, but don't quote me on this one. How can we verify this? Where if I create, for example, if I create a vector Vx, which is a pure vector in the one unit vector in the x direction, and I create a vector Vy, which is a new vector in the y direction, if I do the cross product of these two vectors, I should get the c vector. So let me do that. Why not? So vector cross should be equal to vector dot cross product between Vx and Vy. So let me print everything to the console. So that's Vx. So that's Vx, and then this is Vy, and this is the cross product. Let's see if this works. Woohoo! It looks like it works. So we get a vector that is perpendicular to these two, so in the c direction, and the length is equal to the parallelogram that they form. So because it's a square of 1 unit length, then the area of that is 1 unit. So that's great. So it looks like it's working so far. Now, this is actually a very interesting example. I'm going to clear all this up because something that is also super common when working with vector algebra is needing to generate quick or fast, needing to generate unit vectors in the x direction, the y direction, and the z direction to do simple operations like these ones. So instead of actually having to go through typing new vector 1, 0, 0, 1, 0, 1, whatever, blah, 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 actually, a very common thing to do is, and this is also, we're starting to get also in the advanced kind of ways, is implementing in the class, implementing static properties, so implementing global properties that what they do is they generate automatically these canonical vectors in a way that we don't need to manually use the constructor to create them. So for example, let me show you an example of that. We're going to go here to properties, all right? And I'm going to create a static property that is going to be called here. It's going to be of the type vector, and it's going public static, all right? It's going to be a static property. Static properties. Static vector call, and I'm going to call it x-axis, all right? This is a very common thing to do. And what I'm going to do is, this is going to be only of the type get. So I'm not going to be able to force to write to this property. And whenever anyone calls the static property x-axis, what they're going to be given back as a result is going to be, they're going to be returned a new vector in the x direction with 1 unit long. All right. Or if you wanna do shortcut things, this is also a way to shortcut that expression. Okay, whichever one works for you. What this allows me to do is that now I can shortcut this a little bit by saying now instead of having to manually generate this x vector, I just want to go to the class and ask the class to give me, you can see here, a canonical x-axis vector. All right. So it feels like it's a property. It feels like it's always the same x-axis vector. It's easier to write, it's easier to type, easier to read. But at the same time, what's hiding under this expression is that the class is basically giving you a way, it's giving you a name to automatically generate vectors in the x direction. All right. Similarly, we can just create a y-axis this is going to be 0 and 1. And we can also generate a z-axis that is going to be an axis 0, 0, 1. Okay? And then I can rewrite this now to say vector dot z-axis. Oh, sorry, no. Well, let me say y-axis, sorry. And if I run this code, things work exactly the same. 1, 1, and then the other vector. Okay? All right, so this is looking great so far. What else can we do? What else can we do? Oh, let's take a look at manual operators. What? But what do I mean with overriding operators? Okay, so I have cleaned up a little bit of the old code, and I have gone back to where we implemented addition between two vectors, right? And you could argue like, oh, okay, well, I understand, yeah, vector dot addition, blah, 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 gives me a new one, right? But you know what? It's just adding two things together. So it feels like it would be super interesting to have the capacity to say V2 should just simply be equal to V0 plus V1. That's it, you know, so simple as that. But we can't. So this is giving me an error because it says like, oh, I cannot use the operator plus between two things of the type vector. I only know how to add two numbers. I don't know how to add two vectors. All right. So can we actually teach the computer how to use the plus operator to add two vectors together? Indeed. There is this thing called operator overloading. All right. We have not seen that on the previous videos that I have posted, or maybe if you're watching this in the future, maybe I already did a video on that, and what I'm saying right now is not true. It doesn't matter, but I'm just going to explain it again. The idea is that just like I have created methods and functions and blah 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 with their own particular names, what I can do is I can also override, or I can create shortcuts to teach the computer how to use operators that are common for other arithmetic operations, but instead of using primitive types like numbers, by using custom types that I have generated, like the vectors. So how does that work? Well, the way it works is that they are static operators. So what that means is that I'm going to go all the way down here where I have my static methods, and before the addition one, or after, it doesn't really matter where you do it, all right? What I can do is I can create I'm just going to create a operator overloads. And what I can do is I can say I'm going to create a new public static thing. And this thing is going to be overriding the operator plus, okay? All right, but then the operator plus, I need to be the one who defines what are the two things that the operator can add together. So these are going to be defined as arguments of a function. So I'm going to say vector A and vector B, all right? I'm going to open and close curly brackets, but as everything in C#, because C# is strongly typed, it also needs to have a return type. So when I add two vectors, for us, it might be obvious that the result of that operation needs to be a vector, but for the computer it's not. So we just need to specify when we add two vectors with the plus operator, the result is going to be a vector. It's going to be something of the type vector. And what are we going to do here? Well, something that I could do is I could just copy paste this. I'm going to add the components, blah, 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 whatever, and then I'm going to return V. Or whatever I want, I can also, instead of being redundant with code, what I could do is I could say, I'm just going to call this method here. I'm going to call return vector dot addition, and then the addition between A and B. So this thing here is going to be calling this method here. All right. So one is calling the other, or I can duplicate the exact same code on both of them. I don't like duplicating code, even though duplicating code sometimes is a bit more optimal in terms of performance, but not in terms of code maintainability. So I'm just going to keep it here. All right. So And then by doing that, now you can see how I don't have an error here, vector v2, all right? And then I can console write line the result of adding these two vectors, which is 4, 6, and 3. Okay? Similarly, for example, I could override the multiplication operator. You know what? I'm actually going to return, so that it's a bit easier to read, vector addition A and B. I'm just also going to override the multiplication. So static operator, the multiplication symbol, and I'm going to say vector A and vector B. Okay? And what is going to be the result of multiplying two vectors? Typically, simple multiplication of two vectors is typically understood as the dot product. Therefore, the result of this operation is going to be a double. It's going to be a number. And then the return of this operation could be vector dot product A and B. So whenever I call multiplication on two vectors, what I'm actually doing is the dot product between them. All right? So here I could say double dot is going to be equal to V0 times V1. And now console and the dot product of these two. And I also get the value of 11 right now. All right? Even more. Wait. Let me show you another trick. When I multiply things, they don't have to be the same type. They can also be different types. So remember when we said that we could scale a vector, right? But when we did scale a vector, we scaled it in place. We changed that vector. But maybe what I want to do is I want to have something where I can say, for example, vector v22, so 2 times 2. I want this to be 2 times the vector v2. All right? So, and I want to be able to print that to the console. This is fine, but the problem is that I have defined how to multiply two vectors together, but I have not defined how to multiply a vector and a double. The computer doesn't know how to do that. All right? So the way to do that is by defining somewhere in the overloads an overload for the overload. So just like here, I have defined an overload for the multiplication symbol, and I have specified that this can take two vectors. Then something that I can do is I can say, I'm going to do the same thing. All right. I'm going to say, oops. I'm going to define an overload, a static overload for the operator multiplication symbol, but this time it's going to be between a double A and a vector B. All right. And if I do that, the return type of multiplying a number by a vector is going to be a vector that is a little bigger or smaller depending on how it gets scaled. So the return type is going to be that. Okay? And then what do we do? Well, something that I can do is, for example, I can create a vector that is going to be called V, which is going to be a copy of the vector that has been given to me here. All right? Because remember, I may not want to change the vector V that has been passed here by reference. And then what I can do is I can say I want to scale that vector by the factor that has been given me as a number. So I want this to be the vector that I change, not vector B. So you see here, this is a good example of why I may want to make copies of vectors. And now I can just return V, and that should work. Let's prove that this works. So I'm going to, this is now working, but let me also print again V2 to make sure that it hasn't changed. All right. So we have V2, we have V2 multiplied by 2, we have V2 again, it hasn't changed, and we have the dot product between the two vectors. All right. How awesome is this? Huh? How cool is this? And the last thing that I want to touch upon on this example is indexers. All right. I haven't shown that in my previous videos, or I may have written a new video that I'm not after this one. But the idea is that we can we can overload multiplications. We can overload addition symbols, etc. There is another tool that we can add to our classes, which is the fact that we may want to be able to retrieve data from that class by, instead of referring to the name of the object, of the name of the property, we may want to be able to refer to some of the properties by using square bracket notation and an index number, just like we do for lists and for arrays. So so I may want to do something where I may want to be able to get the x property of v0 by saying I want to take v0.0, and I want to do the y property, I want to do v01, and the c property v02. Okay? Why is this interesting? Well, sometimes we may want to write code that uses a lot of for loops and uses a lot of iteration to work with the object that it uses. So maybe we want to be able to pass in objects that accept being read using indexer notation. Okay, it's not a super common thing, but it's a nerdy enough thing, and it really fits the vector class, for example. So I thought that maybe we could just implement it. So it's actually quite an easy thing to do, and the idea is that the way to do that is by writing what's called an indexer. An indexer is a way of saying, if you give me square bracket notation and an integer number, then I know what to give you back from this. So what does that look like? The way to do that is by writing, I'm going to define a public indexer that is going to return a double. Okay? And what I do is I use the this keyword, and then I open square brackets, and I say, if you give me an integer that I'm going to call I, then I will know what to give you back. All right? And then what I can do here is I can say, if you want to read, okay, then what I'm going to do is I'm going to say, if I equals 0, all right, then return this dot x. Otherwise, if I equals 1, then return this dot y. Otherwise, if I equals 2, then I should return this dot c. Okay? And so this is the basics. However, this is giving me an error because since I have 3 conditional statements for 0, 1, 3, there might be the case where the user gives me a number that is not valid. So something that is less than 0 or something that is greater than 2. And in that case, my code would not return anything here. So I need to be able to make sure that I either return something. So for example, I can return null, or instead of returning null, I must be able to say, oh, I think you gave me something that was wrong, so I'm just going to throw an exception. I'm just going to throw a new exception. Okay? Period. So how does that work? So in this case, this code is going to work, and nothing prints out because I haven't really printed anything out. But if I were to say double W and I want to be v0.4, for example, and I run this code, you can see that I have an unhandled exception because something is not working properly. Okay? And then, similarly, what I can do is I can say, well, but if you want to write to these things, I can say, well, I'm going to copy this structure. If I is 0, then this dot x equals whichever value you're giving me. All right? And otherwise, this dot y, and then this dot c. And if you give me something else that is not 0, 1, or 2, then I will throw an exception. All right? And by doing so, what I can do now is I can say v0, 0, wait, sorry. I'm going to keep what I had here. And then v0 is going to be equal to 3 point blah, blah, blah. v01 is going to be equal to whatever, another number, and v02 is going to be equal to this other number. And let me print this to the console, v0. And as I do that, up, what have I done here? All right, sorry, I found the problem. It's a little late here. I've been recording all day. Yes, so because of the way I wrote the if else, the code changes the values, but it always ends up throwing the exception here. So what I need to do is I need to just wrap this into, if none of the above was true, if you gave me a number that is not 0, 1, or 2, then that's when you need to throw the exception. Not always, all right? And I think this code should work now. And yes, I do have this new vector with these weird numbers that I just created. Okay. All right. And I think with that, I have covered everything that I wanted to cover. And I think I have given you a pretty good sense of an interesting and fairly comprehensive way of writing a vector class that has a lot of functionality about how to work with vectors, scaling them, unitizing them, overwriting the operators, which is a really common and cool thing to do with vectors, writing static methods, and even customizing how they get turned into strings. Okay, there are more things that we can do. We can add operations on how to calculate angles, or whether if the vectors have like valid operations, or I don't know. There's a lot of things that we could add here, but for the sake of illustrating how to create a class, I think I'm happy with this level. And I actually think we touched upon some fairly advanced topics, many of which are very particular to C#, for example, operator overloads and that kind of stuff. So I think I'm fairly happy with this. So thanks a lot for sticking around to this video. So my name is Jose Luis, this is Parametric Camp, and we do a lot of computational design videos on learning how to code and doing it in creative ways. So if you did like this video, please, it would be nice if you could subscribe to the channel, hit the notification button, like this video, and all those things that help us promote this content on YouTube. And if you also like the spirit of the things that we're touching upon, how to write code for creative purposes, I have a lot of videos in the channel that touch upon other topics. For example, computational geometry, interactive things, algorithmic modeling, and all those topics that I think might be interesting for you. So you're welcome to check them out. In the meantime, thank you very much, and hope to see you in some other video.